Hello, good everyone. So at this point of time, let us talk about testing the difference between two proportions. So this is the two proportion of z-test, and we are going to use a critical value method. So what is the overview and the purpose of this z-test or test of difference between proportions? These the t-test of difference between proportions determines whether the two population proportions are significantly different based on the sample data. So when to use or what is the use of this t-test? When the variable is categorical like yes or no, pass or fail, male, female, support or oppose, or two independent samples are taken, or you want to compare the proportions, not means. We are going to take note this is to compare proportions, not means. So there is a procedure table. Here's the procedure table that we're going to do when you're using tradition method. First step is we need to state the hypothesis and identify the claim. And step number two, we have to find the critical values from the appropriate table in Appendix A and compute the test value. And step number four, make the decision to reject or not to reject the null hypothesis. And step number five, we have to summarize the results. And there are assumptions for the z-test for two proportions. The first one is that we need to have the samples must be random samples. So take note of the word random samples. And number two, the sample data are independent of one another. So it should not be that is not related. So both samples NP is greater than or equal to 5 and NQ is greater than or equal to 5. So we have to take note that this is both samples NP is greater than or equal to 5 and NQ is greater than or equal to 5. So the formula for z-test, this is the formula for z-test. So this is the p hat minus p hat 1 minus p hat 2 minus p1 minus p2 over the square root of p bar q bar times 1 over n1 plus 1 over n2. This is square root. So how to get the p bar? X sub 1 plus x sub 2 over n minus 1 plus n minus 2. And how to get the p hat 1 is equal to x sub 1 over n1 and the p hat 2 is equal to x sub 2 over n sub 2. And how to find the q bar, or this one, the complement. So 1 minus 1 minus the p bar. Okay, so the sample population proportions. So we have to take note that this sample 1 proportion, x sub 1 means to say the number of successes in sample 1, and n1 is the sample size for group number 1. For p hat 2, that is x sub 2 over n2, this one is equal to x sub 2 is the number of successes in sample 2, and n2 is the sample size for group number 2. So what do you mean by p bar? This one is the pooled proportion. This is what we call as pooled proportion. And we have here the pooled q, that is q bar minus 1 minus p bar. So the difference between the sample proportions minus the hypothesis difference, often that is equal to 0. So we have to take note the denominator. This one is the what we call as the standard error of the difference between two samples using the pooled estimate. Okay, let us have example number 1. In the nursing home, study mentioned in the chapter opening statistics, so they found out 12 out of 34 randomly selected small nursing homes had a resident vaccination rate of less than 80%, while 17 out of 24 randomly selected large nursing homes had a vaccination rate at less than 80%. At alpha 0.05, so we have here test the claim that there is no difference in the proportions of the small and the large nursing homes with a resident vaccination rates of less than 80%. So we have to follow the traditional method, which is the first step is we have to state the null hypothesis and the alternative hypothesis or the hypothesis. So the first one, we have here identify the claim. So we have here the null hypothesis HO. We have here proportion 1 is equal to proportion 2. And our H1 is proportion 1 is not equal to proportion 2. So in this case, we have to determine what is our claim. So the question here tests the claim that there is no difference in the proportion of the small large nursing homes with a resident vaccination rate of less than 80%. So it means that this would be our claim. So our HO is our claim because the word there's no difference in the proportions of the small and large nursing homes with a recent vaccination rate of less than 80%. So step number 2 is we need to find the critical values. So how to find the critical values? So the critical values, we have to locate that one in the Z table. So at alpha 0.05, let us locate that one in the Z table. 0.05, okay, 0.05, and this one is a two-tailed test. Okay, so when we talk about two-tailed test, so we have here the alpha is equal to, okay, the alpha is equal to 0.05 divided by 2. Okay, so therefore we have 0.975. Okay, so we have here, since the alpha, this is a two-tailed test, so we have to divide the alpha. 1 minus the alpha divided by 2. So we have here 1 minus the alpha 0.05 divided by 2. So 1 minus alpha is 0.05 divided by 2. Okay. This is 0.975. So if we're going to locate 0.975 here, okay, you have going to locate 975. So this one. Okay. There is 1975. This is 1.96. So this one is negative. So therefore, the critical value that we have is equal to positive and negative 1.96 because this is a two-tailed test. So this one, okay. So this one is the two-tailed test, so negative 1.96. And here also, this is positive 1.96. Okay. So the critical value is equal to 1.96. So next is we need to compute the Z value, how to find the Z value by using the formula. So we have here P bar is equal to X sub 1. So we have to find for the P hat, P hat 1, P hat 2, and P bar and Q bar. Or this one are the followings, no? So these are what we call as, okay, this one, we have to find the pole proportion and the pole Q. Okay, we have to find the pole proportion and also we have to find the sample proportion and the sample proportion too. Okay, so first, so we have here sample proportion 1. So P hat 1 is equal to X. What is our X here? Our X sub 1 here, based on the statement, is 12 out of 34. So therefore, our N is 12 over 34. So this is equal to 0.35. Next, we have here P hat 2. Okay, so the next one is 17 out of 24 randomly selected. large nursing homes and vaccination. So 17 over 24 is equal to, we have 0.71. So P hat 2 is equal to 17 over 24, that's 0.71. And the next step that we're going to do is we need to find the pole proportion. So the pole proportion, we have P bar is equal to x1 plus x2 over n1 plus n2. So we have here, what is our n1? X sub 1 is 12 plus the next one is 17 over, what is our n1 is 34 plus 24. So we are going to add this one. We have 29 over 58. What is 29 over 58? That is equal to 0.5. Okay. The next one is we need to find the pulled Q. Okay, Q bar here. So 1 minus P bar is equal to, what is 1 minus 0.05? That's equal to 0.5 rather. 0.5 is equal to 0.5. Then after which we have to use the formula. So the formula now here in step here, continue here at Z. Okay. The formula now is P hat 1 minus P hat 2 is equal to minus P1 minus P2. This minus over the square root of P bar Q bar, the square root 1 over N1 plus 1 over N2. P hat 1 minus P hat 2 is equal to 1 P1 P2 square root of P bar Q bar 1 minus P bar 1 plus 1 over N1 plus 1 over N2. So now we have to compute. So we have the following results. We have here the proportion 1, so proportion 1, sample proportion 2, the pole proportion, and the pole Q. So by substituting in the formula, okay, Z. So we have here 0.35 minus, okay, we have 0.71. And what is P1 minus P2? Based on our hypothesis here, P1 equals P2. So we could equate this one as P1 minus P2 is equal to 0. So therefore we have here 0. Minus 0 over the square root of. So we have here 0.05 as our Q bar. And P bar also 0.05 over the square root of, multiplied by, rather, 1 over 34 plus 1 over 24 equal. So we have to compute. So 0.35 minus 0.31, 35 minus 0.71, that's equal to negative 0.36 over, so compute this one, square root of 0.05 times 0.05 times the square root times 1 over 34 plus 1 over 24. The result is 0.1333. So this is 0.36 divided by 0.133. The resulting one is 2.7. So this is negative 2.70. Okay, 2.70. So step number 4, we are done with step number 2. And this is step number 3 rather. Step number 3. And step number 4. In step number 4, we have to make the decision. So since our critical value is equal to positive and negative 1.96, if we're going to graph that one, okay, that is a standard normal distribution curve. So if this is negative 1.96, and we have here our z value is negative 2.70, so this is in the part of the critical region. So there is a rejection region, so therefore we have to reject the null hypothesis. Reject the null hypothesis since negative 2.70 is lesser than negative 1.96. So that is based on the illustration. So these are the critical regions here. And step number 5, okay, step number 5, we have to summarize the result. So we have here, there is enough. Since we have rejected the null hypothesis, there is enough evidence to support the claim that, okay, what is our claim? So let's go back here. Our claim is there is no difference in the proportions of the large and proportion of large nursing homes with a recent vaccination less than 80%. So we have to copy this, claim that there is no difference in the proportions of small and large nursing homes with a resident vaccination of less than 80%. Okay, so we are done with problem number 1. So we have step 1 to 5. So let's proceed now with problem number 2. So a survey of 200 randomly selected male and female workers, 100 in each group, found that 7% of the male workers said that they worked more than 5 days per week, while 11% of the female workers said that they work for more than 5 days per week. At alpha 0.01, can it be concluded that the percentage of males who work more than 5 days is less than the percentage of females workers who work more than 5 days per week? Okay. Step number 5, this is source based on the study of fit survey of workers. So let us have step number 1. Step number 1, we have to state the hypothesis and identify the claim. So our HO here is proportion 1, sample proportion is equal to sample proportion 2. And our H1, it's stated here that can it be concluded at the percentage of males who work the 5 days per week is less than the percentage. So the meaning to say we have your proportion, sample proportion 1 is lesser than sample proportion 2. And this would be our claim based on the statement that can it be concluded that the percentage of males who work more than 5 days per week is less than the percentage of female workers who work more than 5 days per week. Then after that one, we have to find the critical value. So to find for the critical value, which is alpha is equal to 0.01. So see, this is the critical value So we have to locate here. So, okay, 0.01. Okay, let's go back here. Okay, let's find here 0.01. So here, the closest one is this one, 0.01, 0.099. So we have to use this as the closest one. So therefore, this is negative 2.33. So our critical value at 0.01 is negative 2.33. So the next step that we're going to do is we need to find the sample proportions 1 and 2, the pole proportion and the fold Q. So let's start with okay, we have to find first what is the value. Okay, we have to find first what is the value of our x sub 1. So since we have already the percentage, so pole proportion 1 is x1 over and 1. So since the given is the percentage already, which is 7%, which is our pole proportion 1, so we have to convert this one as we need to find the value for our x. The value for x sub 1 is equal to n1 p proportion 1. So we have here our n1 is equal to 100 times the proportion is a 0.07. So this would become 7. So therefore an x1 is 7. And our x2 is equal to, same process here, x2 p2 100 over times 0.11. So we have here 11 r our x sub 2. Since we need to find the pole proportion, so we have x sub 1 plus x sub 2 over n1 plus n2. So we don't need to find the pole proportion 2 and 1 because that is already given, which is 70%. Those are already given, which is 7% or and 11%. So what we're going to do here, in order to find the pole proportion, we need to get the value for x sub 1 and x sub 2. So to find for the value for x sub 1 and x sub 2, we have to use the formula n1 times proportion 1, sample proportion 1. So 100, because in each group, we have 100. So 100 times 0.07 is equal to 7. So in this case, we have here x sub 1. What is our x sub 1 now? Is 7. And our x sub 2 is plus 11 over each group has 100. Okay, so 100 plus 100. So we have 18 over 200 is equal to 0.09. So we have now our pole proportion. So next is we have here the pooled Q. So 1 minus pole proportion is equal to, we have here 1 minus 0.09. So 0.09, 1 minus 0.09, so we have to subtract this one, we have 0.91. So we have now the completed value for our z proportion. So let's proceed now with step number 3, which is by computing the z value. So step number 3, okay, step number 3, so z is equal to, we have the proportion 1 minus sample proportion 2 minus p1 minus p2 proportion 2 over the square root of bar q bar times 1 over n1 plus 1 over n2. So the given here is the proportion 1 is 7%, right? So we have here 7% and the pole proportion 2 is 11%. So we have here 0.09 0.07 minus 0.11, and this one would become 0 because there's no difference. So minus 0 over the square root of, we have here 0.909 and 0.91. So substitute here in the value. Our P bar is 0.09 and our Q bar is 0.91 times 1 over 100 plus 1 over 100. So if we're going to compute that one, 0.07 minus 0.11, that is equal to negative 0.04 over what is our 0.09, 0.91 times times 1 over 100 plus 1 over 100, that is equal to 0.0404. So the result of this one, when we divide negative 0.04 by 0.0404, is equal to negative 0.99. So now we have here the value for z proportion, so we have to compare it with the critical value. So we have to make a decision. Step number 4, so we have to make the decision. So what is now the decision? Okay, we're going to graph. So the decision now is our critical value, which is negative 2.33. Okay, negative 2.33. This is non-rejection region, but that is negative 0.009. Okay, 0.099. Okay, negative 0.099. So that is not part of the rejection region. So therefore, to make it for the decision making, so do not reject. Okay, we have do not reject because this falls within the non-critical region. So do not reject null hypothesis since negative 0.099 is greater than negative 0.233. Okay, so 0.99 is in the non-critical region. So we have here step number 5. Okay, step number 5. So we have to summarize the result now. So there is not enough evidence to support the claim that the proportion of men who say that they work more than 5 days a week is less than the proportion of women who said that they work more than 5 days a week. Okay, there's not evidence to support the claim that the proportion of the men who say that they work more than 5 days a week is less than the proportion of women who say that they work more than 5 days a week. Okay? So now, this is try this at home. So there are 2 problems that we're going to solve and submit that one during our meeting. So thank you so much. Do not forget to comment your answer here in this YouTube channel, and please answer this to try this. God bless everyone.